Hello students, welcome to my class. In this video, angle of banking, non-uniform circular motion, vertical circular motion problems we are going to be discussing. Let us see the first question. In angle of banking, a cyclist turns around a curve at the 15 miles per hour it's given. If he turns at a double the speed, the tendency to overturn is. Cyclist, when he is moving in a curved path, in the sense here when he is making a turn, in the sense here so here towards its center, here it's going to be acting, centripetal force is going to be acting, that is mv square by r will be getting. Now here if he turns double the speed, in the sense here what the tendency to overcome. So force becomes how many times they are asking. Simply here you just take here fc equals will be getting as mv square by r, and here f is directly proportional to here you can take as v square. Then let us take as f2 by f1, which will be equal to your take as v2 square by v1 square. That means here doubling his speed, so here we'll get take as 2v by v whole square you can take. So vv gets cancelled, we'll be getting as 4 times we'll be getting. Then force he has to increase as 4 times of the initial force he has to be increases. It becomes quadrupled. Let us see the next question. The next question says, an aircraft execute a horizontal loop with a speed of 150 meter per second. So its a speed is given with its wings banked at an angle of 12 degrees. The radius of the loop they are asking. Here an aircraft he is going to be making a horizontal loop, he is going to be making, and here there is an aircraft, suppose here you are taking, and here this is the horizontal you can take. So here it's making an angle like 12 degrees it's given, and here at this point here you can take as when he is making a turn, the aircraft when it is making a turn at this point you can take here. So this is a lifting force you have to imagine. This lifting force here and here the weight of this aeroplane, it's going to be acting downwards when it is making a turn mg, and here this lifting force when you are resolving, and this is like 12 degrees it's given, like let us take that this one as theta you can take, and here this is the horizontal value, and here it will be, so here you just take this is, if this is theta in the sense here you will be getting as, if you are making this is theta and here it is also a theta will be getting, and here you can take this is f cos theta you can take when you are resolving, and this will be f sin theta you can take, and outward force is going to be balancing, that is a centrifugal force will be getting. Now when you are simplifying at this position, when you are taking the equilibrium condition, here f cos theta can be balanced by mg, and here f sin theta can be balanced by the centrifugal force, that is mv square by r will be getting. So when you are simplifying this one, here you can take as equation 1 and 2. When you are simplifying this one, this is tan theta you can take here, like you can take as 2 by 1 you can talk, 2 by 1 when you are taking, this is mv square by r by mg, it will come to the denominator, gets cancelled, so tan theta which will be equal to will be getting as v square by r will be getting. So theta value already it's given as 12 degrees is given, so here you can take as tan 12 degrees which will be equal to velocity is given as 150 into 150 by its a radius is given as, we need to calculate the radius, into g value it's given as 10 is given. So here when you are simplifying this value here, tan 12 degrees nearly will be getting as like 0.212 like that will be getting. So these values they can give you in the examination time. So tan 12 degrees approximately will be getting as 0.212 will be getting when you are substituting these values. So the radius of the loop will be getting as nearly, so you will be getting in meters, that meters nearly will be getting as 10,613 meters you are getting, that you need to convert into the kilometers, nearly will be getting as 10.6 kilometers you are getting. So 10.6 kilometer is the correct answer. Let us see the next question. A motorcyclist moving with a velocity 72 km per hour On a flat road, it takes a turn on the road at a point where the radius of curvature of the road is given as 20 meters. The acceleration due to gravity is given as 10 meter per second square. In order to avoid skidding, he must not bend the respect to the vertical plane by an angle greater than. So a motorcyclist, he is going to be making a turn, it's given. So here also I just take here is going to be making a turn, you can take. So here this is a motorcyclist person, you can take, he is making a turn. So at this position here weight of the person is going to be acting downwards. So here this is a normal reaction at the point of contact with the vehicle. Here it's going to be acting like this. This is a normal reaction. And here this normal reaction with the vertical, you can take, if it is making an angle theta, this is n cos theta, you can take. And here perpendicular to this one, here you can take as n sin theta, you can take. And this an outward force can be balanced. One is here you can take as centrifugal force, you can take. Then here also you just equate the components here. So here n cos theta, which will be equal to, will be getting as mg, and here n sin theta can be balanced by, here you can take as mv square by r, you can take. That means here when you are simplifying, let us take that this is equation 1 and 2, and here again you can take as 2 by 1. Then you are getting as tan theta, which will be equal to, you can get it as v square by r, you will be getting. So initial velocity is given as 72 km per hour. You have to convert 1 km per hour equal to 5 by 18 meter per second. So 18 fours are, so velocity will be getting as 20 meter per second will be getting. So kilometer per hour is a practical unit. It is neither SI unit or nor CGS unit. You need to convert into SI unit. So here tan theta, which will be equal to, here will be getting as v square, in the sense 20 into 20 by its radius is given as 20 meters is given. G value you can take as 10. 120 gets cancelled, 10 2 times. So here theta equals to tan function, you can take that side. Here it becomes tan inverse 2 will be getting. This is the correct answer. Let us see the next question. The road is given as 10 meter wide is given. Its radius of curvature is given as 50 meter. Road 10 meter is going to be giving wide, and here the outer edge is above the lower edge by a distance of 1.5 meter. So this road is much suited for the velocity. Here let us take when an inclined plane, we just take students here. Right here, when a vehicle is going to be moving, suppose here if any vehicle is going to be moving, and here a width of this road is given as here 10 meters is given, and here this is an outer edge of the road, you can take. Here you just imagine like this. This is a road, you just imagine like this. This is a road, you just imagine like this. Here with the horizontal, it's making an angle like some theta, you just take like this, right? And here this width of the road is given as here 1.10 meters is given, and here the outer edge, this is an outer edge you can take, this is an outer, and here this is the lower edge you can take, lower edge you can take, and here the outer edge with the inner edge, here lower edge, it's going to be given as 1.5 meters distance is given. Now here this road must be suited for what velocity? Suppose if the vehicle is going to be making, here it's going to be moving like this. If it is going to be moving like this, at this point here we just take, this is a normal reaction where it is going to be contacting, and here total vehicle weight, it's going to be acting downwards, and here normal reaction when you are going to be, again here when you are going to be simplifying, and here this is theta will be getting, and here this will be the 90 minus theta, and here again we will be getting this is theta will be getting, and this will be n cos theta you can take, and this side will be getting as n sin theta you can take, and here this n sin theta can be balanced by, here you can take as it's an outward force mv square by r you can take, that's the centrifugal force. Again you just simplify this one, here again you can write it as n cos theta, which will be equal to mg you can take, and n sin theta which you can take as mv square by r you can take. Then when you are simplifying again here, I can get it as tan theta which will be equal to, will be getting as v square by r will be getting. So from this triangle here, tan theta which is nothing but here, this is an opposite side will be getting, and this will be the adjacent side. So you can take as 1.5 by 10 you can take, which will be equal to. So we need to calculate here the speed value v square by r value you can take as somewhere here, the radius of the curvature will be getting somewhere here. This is the radius of curvature, it's given as 50 meters is given. Right here, this is the radius of curvature you can take. It's a 50 into g value you can take as 10 you can take. 10 gets cancelled. V square equals will be getting as 50 into 1.5, which is nothing but here will be getting as 15. Pfizer will be getting as 75 will be getting. Then velocity here will be getting as nearly, it's an 8.5 meter per second will be getting. This is the correct answer. Let us see the next question. Here a boy on a cycle pedals around a circle of 20 meters radius at a speed of 20 meter per second. The combined mass of the boy and the cycle is given as 90 kg. The angle that the cycle makes with the vertical they are asking. So let us take here a cycle wheel you are going to be taking. Let us take one cycle wheel, students. Here this is the cycle wheel, you just imagine. And here this is a bicycle, you just imagine. And here you can take, it's going to be making a turn. And here let us talk about here at the point of contact here you can take, and this is the normal reaction you can take. Here this normal here which is making an angle theta with this line you can take with the vertical. They are asking this theta value. So normal when it's making an angle here, this is n cos theta you can take, and perpendicular to this one you can take as n sin theta you can take. And here you can take as, here it's an outward force you can take as. So at the point of contact of this cycle wheel here, weight it's going to be acting downwards you can take, and here an outward force you can take as mv square by r you can take. Again here when you are simplifying these things here, n cos theta can be balanced by mg, and here n sin theta can be balanced by, here you can take as mv square by r you can take. And here they are asking here the angle that the cycle makes with the vertical, this angle they are going to be asking. So when you are simplifying here, this is 1 and 2 you can take, and 2 by 1 when you are taking here tan theta which will be equal to, will be getting as v square by rg will be getting. So that means here tan theta value, here v value is given as 20 meter per second. Here you can take as 20 into 20 by, and here a circle of radius is given as 20 meters is given, and here you can take as z value you can take as 9.8. So nearly will be getting as 20 by 9.8, and here theta value will be getting as nearly, when you are calculating, 63.9 degrees you are getting. So this is the correct answer. Let us see the next question. The radius of the curved road on a national highway is given as r is given. Width of the road is given as b is given. The outer edge of the road is raised by h height. And here also you can take the same scenario, students. Here earlier also we have seen, and here it's given as width of the road it's given, and here the outer edge which is going to be raised by some height is given as h is given. So they are asking that height value. Let us take here this is theta you can take, and this is the h is the height, this is an outer edge you can take, outer, and this will be the inner edge you can take, inner edge you can take. Now here any vehicle is going to be moving, it's making a turn on this one. Here this is the curvature, you just imagine, This is the curvature, you just imagine. And here somewhere here at the center here you can talk about its radius. So the wide width of the road is given as B is given. This is the width of the road we can take, students. And here with respect to the inner edge, here it's making a height. Outer edge is making, with the inner edge it's making a height is given as H is given. Now here you can take when it's going to be making a turn, and here at the point of contact here you can take, here normal reaction it's going to be perpendicular to the surface of contact, and here this is theta, and here also you can take as this is weight you can take as mg, and here when you are resolving this is n cos theta will be getting, and here will be getting this is n sin theta will be getting, and here an outward force you can take as mv square by r you can take. So again when you are simplifying these values, here tan theta which will be equal to will be getting as v square by r will be getting, and from this triangle tan theta equals opposite side will be h, adjacent side will be getting as b will be getting, and this is a b value you can take which will be equal to v square by rg. Just they are asking simply height they are asking. So h equals to, here you can get it as v square b by r into g you can take. Radius is given as capital R is given into g you can take. So first one is the correct answer. Let us see the next question. A circular radius road of radius is given as 1000 meter, has a banking angle theta value is given as 45 degrees. The maximum safe speed of the car having a mass is given as 200 kg will be. The coefficient of the friction between the tire and as well as the road is given as 0.5 is given. So here the maximum safest velocity they are asking under the frictional force. Let us take here one vehicle is going to be moving on a curved path on a circular road is given. This is a vehicle you just take, and here this is a curvature you can take. It's making an angle right, theta is given. Let us take theta value is given as 45 degrees is given. This value will be 45 degrees. So here at the point of contact here you can take as normal reaction it's going to be acting. Here it's going to be acting perpendicular to this one, and here this is theta means here you'll be getting as this is, and here normal also here this is theta will be getting, and this will be 90 minus theta, and here will be getting as theta will be getting, and this will be n cos theta will be getting, and this will be n sin theta will be getting. And here an outward force you can take, this is mv square by r you can take, and this will be the n sin theta. Now here you can talk about one more force is going to be acting along its surface, that's a frictional force. When it is making a turn like this, here frictional force along this one, here it's going to be making like this along the tangential, this is f you can take. F now it's making an angle theta with this line, then you just resolve this one. Here you'll be getting as f cos theta will be getting along this direction perpendicular to this one. Here will be getting as f sin theta. So before that here a weight of the body, weight of the vehicle also it's going to be acting downwards. So this is an F frictional force resolution you can take. Then F equals you can take as generally mu into n you can talk. Wherever frictional force when you are talking here if the coefficient of friction between the tire and road is given as 0.5, the maximum safe speed can be provided by the static frictional force you can take. Static frictional force when you are talking here, you just resolve these things. Here in the first case here we will be getting as, in the first case here n cos theta which will be balanced by mg, vertical components I am talking here, mu into f in the sense here f sin theta will be getting, f in the sense we can take as mu into n into sin theta you can take. This is the first equation, or else n when you are taking common here, this is cos theta minus and mu into sin theta you can take, which will be equivalent to here you can take as mg you can take. So let us take this the first equation along its vertical, Now we can talk about the horizontal. So here this side, left side here will be getting as f cos theta, it's going to be acting, and n sin theta also it's going to be acting. And here f cos theta is nothing but f equal to mu into n cos theta you can take, plus here you will be getting as n sin theta can be balanced by, here you can take as mv square by r you can take. And again n, when you are taking common, here you can take as mu into cos theta, plus here we will be getting as sin theta you can take, which will be equivalent to you can take as mv square by r you can take. Let us take this is equation 2 you can take. So here first equation and second equation, when you are simplifying, so here the maximum safe speed will be getting as v maximum safe speed, so v square, which will be equal to, nearly will be getting as, this is here it's 9.8 into this is g into r into, so this is a formula will be getting g into r into, this is here will be getting as mu into mu plus tan theta, by 1 minus mu tan theta I will be getting, by 1 minus mu tan theta I will be getting. And now you have to put these values. G value it's given as 9.8 into, this is 1000 is given radius, and here mu value is given as 0.5 is given, 0.5 plus tan 45 degrees, theta value is given as 45 degrees is given, tan 45 will be 1 by, here 1 minus 0.5 into 1 you can take. So here when you are simplifying this one here, right, so V maximum value, right, V maximum value nearly will be getting as 172 meter per second will be getting, 172 meter per second. Let us see the next question, students. Here a cyclist goes around a circular path of circumference. So circumference of the circular path is given, and here circumference is nothing but we can take as 2 pi r we can take. So which value is given as here 34.3 meters is given. In time it's given as circular path of circumference. To complete one circular path it is going to take as root 22 seconds is given. So here the angle made by the him with the vertical will be. So in the previous questions also we have seen, students, here theta value with the cyclist. Now let us calculate here r value with this, here will be getting as r equals to 34.3 by, here will be getting as 2 pi will be getting, and when you are simplifying this value here you will be getting as nearly 5.46 you are getting. And with what speed in the sense in a circular path, v equals to distance by time you can take. Time taken to complete one rotation will be calling as time period you can take. Here 2 pi into, here this radius value already we calculated 5.46 by root 22 you have to substitute. So this value nearly will be getting as, when you are calculating here nearly will be getting as 7.31 will be getting speed value. And tan theta, the angle with the vertical in the sense tan theta, which will be equal to, will be getting as v square by rg, and here theta value we need to calculate tan theta, which will be equal to v square in the sense here 7.31 into 7.31 by, here we will be getting as, this is r value, the radius you will be getting as 5.46 into, here we will be getting as 9.8. So when you are calculating this value here, both the things it will get cancelled, here it becomes 1. So theta equals will be getting as tan inverse of 1, and here it's nothing but tan inverse of tan 45 degrees, so you can write tan 45 is 1, tan inverse and tan function gets cancelled. So here theta value will be getting as 45 degrees you are getting. Let us see the next question. A cyclist riding a bicycle at a speed of 14 root 3 meter per second it's given. It takes a turn around the circular road of radius is given as 20 root 3 meter without skidding. So here what is his inclination with the vertical they are asking. The same cyclist related question, students. Here you can take here the theta with the vertical in the sense tan theta, which will be equal to, you can take as V square by RG, you can take. So here V value is given as 14 root 3 is given. 14 root 3 when you are squaring on sides, here 196 into root 3 whole square, this is 3 by radius value is given as 20 root 3 is given, and here G value you can take as 9.8 you can take, and here 9.8 and here it will be 20 times, this 20 gets cancelled, here we will be getting as 3 by root 3 will be getting, which is nothing but here you can write it as root 3 into root 3 by you can write it as root 3, and here tan theta equal to root 3, and here means which is nothing but tan 60 degrees you have to write, and here tan function you have to eliminate, theta equals will be getting as 60 degrees you are getting. This is the correct answer. And here a person with his hands in the pocket is skating in an ice at the velocity 10 meter per second is given, and it describes a circle of radius 50 meter. So here what is this inclination with the vertical? So here in the ice, here a person is going to be skating, and here is making a turn like this, is going to be making a turn. So here when he is making a turn, here you can take right here, this is the point of contact you can take, and here normal reaction it's going to be acting like this, weight of the person it's going to be acting like this, and here this is the normal. If it is making an angle theta, this is n cos theta you can take, and here this will be n sin theta you can take. Here an outward force you can take as centrifugal force, that is mv square by r you can take. And here also when you are taking inclination angle with the vertical in this sense theta, you just take here. So when you are simplifying the horizontal component and vertical components, here we will be getting as tan theta equals will be getting as v square by rz will be getting. So speed is given as 10 meter, 10 into 10 by here radius value is given as 50 into you can take as 10. So here on 10 gets cancelled, 10 5 will be getting. So theta equals to here will be getting as tan inverse of here 1 by 5 you are getting. So these are the banking angle questions, students. Let us see the next thing is here. Next concept related is non-uniform circular motion. In non-uniform circular motion, let us see the first question. A car is moving with a speed of 30 meter per second on a circular path of radius is given as 500 meter, and here speed is given as 30 meter per second, and its radius of circular path is given as 500 meters. Its speed is increasing at the rate of 2 meter per second. So speed is increasing at the rate in the sense here, that is at equals to you can write as dv by dt, students, which is nothing but tangential acceleration will be calling. The tangential acceleration value is given as 2 meter per second square is given. So here whenever in the question it is given as increasing at the rate it's given, means here we must talk about the two kinds of the acceleration. One is tangential acceleration and second one is the centripetal acceleration. Centripetal acceleration, you know the formula v square by r. With what speed is moving is 30 square you can take by here you can take as r you can take as 500 you can take. This 2 zeros gets cancelled, here you can take as 9 by 5. And what is the resultant acceleration in the sense here you can take as a net is nothing but here in non-uniform circular motion at square plus ac square, both will be acting perpendicularly. So when you are simplifying this one, this is 2 square plus here you can take as 9 by 5 whole square you can take. So when you are simplifying this one, net acceleration will be getting as nearly 2.7 meter per second square will be getting. This is the correct answer. So let us see the next question. The next question says here a stone is thrown horizontally from a height with a velocity. So here initially the velocity is given as Vx is given along horizontal direction. Along horizontal direction, here you are going to be throwing with what velocity is given in the sense here it's Vx is given as 15 meter per second. So along horizontal direction alone. Then here determine the normal and tangential acceleration of the stone in the 1 second after it begins to move, they are asking. Let us talk about the vertical componental velocity. Vertical componental velocity equal to Vy equals to Uy plus Ay into T. Uy, initial vertical velocity will be 0. Ay in the sense here it will be under the gravitational force, that is G into T. After 1 second we need to, it's began to move, they are given. So it is 10 into 1 that's nothing but 10 meter per second. This is a Vy value. Means here here about this thing here I'm just talking, here it's going to be moving like this with an velocity V. When you are resolving this one, this is Vx and as well as Vy you can take, and here it's making an angle theta, it's given horizontally. With the horizontal it's making an angle theta. With this tan theta equals to, here you can take as Vy by Vx you can take. Vy value here will be getting as, this is 10 by Vx value you can take as 15, 520, 530 will be getting. So tan theta which will be equal to, here will be getting as 2 by 3. When you are making a triangle with this, with the tan function, here this is tan theta, this is the opposite side and this will be the adjacent side, and hypotenuse will be getting as root 13 will be getting. Now let us calculate the tangential and as well as centripetal accelerations. So when the particle is moving and when the particle is going to be coming down, and here this is a particle, it's going to be coming down you can take. So here along this direction, and here at this point when you are talking, here weight, it's nothing but here gravitational force is going to be acting downwards. And let us take here, this is x and this will be the y you can take. And here let us talk about the acceleration resolution. And here along its tangent, here right, tangential acceleration you can talk. And here this is the g you are taking. And here it is given as, this is a straight line it's given, and here it is given as theta it's given. This is theta. And here you can get it as, this is 90 minus theta you will be getting. And here this is the normal acceleration, this is an you can take. This is 90 minus theta in the sense here g, here it's making an angle theta with the normal. Then here when you are resolving, so an is nothing but here g, it's making an angle theta with this line. Then you just resolve here, this is g cos theta perpendicular to this one in the sense tangential acceleration will be getting, that is g sin theta you can take. So now let us calculate the two things here. So normal acceleration is nothing but g cos theta will be getting, which is nothing but g value into cos theta from this triangle. From this triangle you will be getting as cos theta is nothing but 3 by root 13 will be getting. So here g value 10 you can take, 10 into 3 will be 30, 30 by root 13 you can take. So this tangential normal acceleration will be getting as nearly 8.2 meter per second square you are getting. This is a normal acceleration. Let us talk about the tangential acceleration. Tangential acceleration is nothing but we got it as g sin theta. So g sin theta, when you are substituting here, g in the sense 10 you can take, here sin theta from this triangle opposite side will be 2 by here you can take as root 13 you can take. It's nothing but 20 by root 13, this value a tangential which will be equal to nearly will be getting as 5.4 meter per second square will be getting. So these are the two accelerations. So tangential acceleration is 5.4 meter per second square, normal acceleration will be 8.2 meter per second square you are getting. Now let us see the next question. A particle is moving along a circular path. A circular path here it's given, a path of radius is given as 3 meters, radius is 3 meters in such a way that the distance travelled along the circumference is given as, s is given as t square by 2 plus t square by 3 is given. So here the acceleration of the particle at time t equal to 2 seconds it's given. If a distance is a variable value, then immediately you have to get it. And here it's going to be acceleration if they are asking in the sense here the body is going to be moving in a non-uniform circular motion. So now we can talk about the tangential acceleration. We can talk V equals to, you can take as ds by dt. So when you are simplifying this one, t square is 2t by 2 plus here we will be getting as 2t by 3 will be getting. So here 2 gets cancelled and this will be t cube is given. T cube, this is nothing but 3t square by 3, you can take 3 gets cancelled. So here the value will be getting as t plus t square you can get. Now here velocity at time t equal to 2 seconds when you are talking, here this is 2 plus here you can get as 2 square, it's a 4 plus 2 will be getting as 6 meter per second will be getting. So this is the tangential acceleration we will be getting. Now here you can take at equals to, here acceleration when you are talking, here at equals to, you can take as dv by dt. So again when you are doing differentiation, this t plus t square, so d by dt of here you can take as t plus t square when you are taking. So d by dt of t will be getting as 1 and here d by dt of t square will be getting as 2t will be getting. So here 1 plus 2t will be getting. When you are putting here acceleration, tangential acceleration, here you can take at time t equals to 2 seconds when you are keeping, here 1 plus 2 into 2 you can take. So it's nothing but here will be getting as 5 meter per second square you are getting. Now here this is about the tangential acceleration. Now let us talk about the centripetal acceleration. So centripetal acceleration, the formula will be getting as v square by r will be getting. V already we have calculated, that is 6 meter per second. So here you can get as 36 by radius is given as 3 is given. So here we will be getting as 12 meter per second square you are getting. So this is the tangential acceleration and centripetal acceleration. The resultant acceleration is nothing but square root of, here you can take as 80 square plus ac square you can take. So which is nothing but here you can take as 12 whole square 144 and this is 5 square will be getting 169 will be getting. So resultant acceleration a equals will be getting as 13 meter per second square you are getting. So this is the correct answer. Let us take the next question. A particle moving along a circular path with a speed is given as v and its speed is increases by g in 1 second it's given. If the radius of the circular path is r, then the net acceleration of the particle they are asking. Speed is increasing at the rate is given, means at the rate of 1 second in the sense, here it's nothing but tangential acceleration is given, that is g you can take, right, g meter per second square. Now here you can talk about here centripetal acceleration, the formula will be, it's moving in a circular path, it's a v square by r will be getting. Then here you can talk about the net acceleration, a net, which will be equal to, you can take as tangential acceleration plus centripetal acceleration whole square you can take, which is nothing but here you can get it as v square by r, sorry, this is here we will be getting as at is nothing but g whole square you can take, and here this is g whole square plus here you can get as v square by r. V square by r whole square means v power 4 by, you can get it as r square you are getting. So here it's nothing but here v power 4 by r square plus g square whole power 1 by 2. So this is the correct answer. This is the net acceleration of the particle. Let us see the next question. A car is moving with the speed of 30 meter per second on a circular path of radius is given as 500 meter. So this one we have done, students, already in the, it's repeated. Now let us talk about the next question here, vertical circular motion problems. Now let us see the first question. A bucket tied at the end of 1.6 meter long string, so it's a 1.6 meter long string, is whirling in a vertical circle with a constant speed. So what should be the minimum speed so that the water of the bucket does not spill when the bucket is at the highest position? So here a bucket you are taking and you are filling with the water, students, and here you are making a turn, and here you can take, this is a bucket, you just imagine, and here so you are going to be hanging like this without spilling. Here the water, you are going to be rotating the body, rotating the bucket. Now here at the highest point in vertical circular motion we will be calling the critical velocity, will be calling. So here this is the critical velocity, here you are taking as v2 like that. So v at the highest point is nothing but here we will be getting as root over gr will be getting. So this is the critical velocity at the highest point will be called. So here this is critical velocity will be called. So here v equal to, here we will be getting a g into r. The g value is given as 10, r value is given as, here it's a 1.6 meter you can take. So here they are asking what should be the minimum speed they are asking. The minimum speed which will be equal to, here you can take 10 into 1.6, here you can take as root 16. It's nothing but will be getting as 4 meter per second will be getting. This is the minimum speed which you required to move the bucket without spill the water. Let us see the next question. A 1 kg stone at the end of the 1 meter long string is rolling in a vertical circle at a constant speed of 4 meter per second. The tension in the string is 6 Newton is given, right, when the stone is at. Now let us talk about here a stone you are taking, and here this is here the string you can take. Here it's given as 1 meter long it's given, and here this is a stone you are going to be making, and here its length is given as here 1 meter it's given at the constant speed 4 meter per second. The tension in the string is 6 newtons when the stone is at. So now let us take here a mg weight of the stone. Here it will be mg, which you can take as 1 into 10 you can take, students. Mass is given as 1 kg, so that we will be getting as 10 newtons will be getting. So when it's moving in a circular path, in the sense here the centripetal force is going to be acting towards its center, that is Fc equals will be getting as mv square by r. So mass is given as 1, and here with what speed you are making the body to move, in the sense 4 meter per second. So here you can take as 4 into 4 by radius is given as 1 meter it's given. So here we will be getting a centripetal force value will be getting as 16 will be getting. So here tension in the string is given as 6 newtons you need to get. Tension in the string will be 6 newtons when the stone is at. So two cases you have to take, students. So here tension at the top you can take. Tension at the top when the body is going to be making a turn, in the sense here. So tension at the top end and at the bottom end you can take, at the bottom end. When here stone is at this point, in the sense here you can take. So this is tensional force, and here you will be getting as weight of the body will be getting as mg towards the downwards, whereas in this case the mg to lags downwards. Here this is the net force is going to be causing the centripetal force. So here whereas in this case here mg plus t, which is going to be centripetal force you can take. This is a net force provides the centripetal force you can take. Then t at the topmost point here will be getting as mv square by r. So t equal to will be getting as mv square by r minus mg will be getting. mv square by r you got it as 16 minus here mg you got it as 10 newtons. So here will be getting as 6 newtons. Whereas here you can take as tension at the lowest point, in the sense here Fc plus here you can take as mv square by r, which will be supported by the weight of the body. So here tension in the string is nothing but this is the tension force you can take. Tension is going to be acting towards this side. This is the tensional force. Now tension at the bottom, in the sense here you can get it as, this is Fc. Sorry, here at the bottom, in the sense here you can take at the bottom. Tension at the bottom when you are talking, at bottom when you are talking, here this side here tensional force, and here and weight it's going to be acting downwards. So here when it's moving turn, in the sense here t minus mg, which will be equal to will be getting as mv square by r. Then here t equals you can write it as mg plus mv square by r you can take. So at the bottom, tensional force will be getting as mv square by r plus mg will be getting. So here mv square by r you are getting as it's nothing but 16 you are getting, 16 plus mg you are getting as 10. So here we will be getting as 26 newtons. But tension in the string is given as 6 newtons is given. That means here where the location of the body in the sense, here we will be getting as at the bottom of the circle will be present. This is the correct answer. Let us see the next question. The next question says a can filled with the water is revolved in a vertical circle of radius is given as 4 meter and water just not fall down. The time period of the revolution they are asking. So here a can you are going to be filling with the water, and here a vertical circle, water just not fall down. The time period of the revolution. Here also you can take, here this is a critical velocity concept. Without falling here when you are rotating the body. So here you can get it as V equals to, you can take it as root GR will be getting at the highest point. So this is the velocity, critical velocity will be calling, that is root GR will be getting. And here we need to calculate the time period of the rotation. Here this is nothing but radius you are taking. There is a relation between linear velocity and angular velocity. V equal to r omega you can take. Then r omega when you are taking, here r omega which will be equal to root gr you can take, and here it's nothing but omega which will be equal to g into r by, here you can take as r you can take. You just bring inside the root, so here it becomes r square, one r gets cancelled. So omega you can take as 2 pi by t you can take, which is nothing but root over g by r will be getting. So with this you have to simplify time period, which is nothing but 2 pi into, here you can get it as root over r by g will be getting. This is the radius value. So 2 into, here you can get it as 3.14 into radius value. So radius is given as 4 meters is given, 4 by you can get it as 9.8. When 9.8 when you are taking outside, 2 into 3.14 by root over 9.8 you can get it as 3.14, root over 4 in the sense 2 you can take, this will get cancelled. So time period 2 into 2 will be getting as 4 seconds you are getting. So this is the correct answer. Let us take the next question. A 2 kg stone at the end of the string, 1 meter long, is whirling in a vertical circle at a constant speed. So the speed of the stone is given as 4 meter per second. The tension in the string is given as 52 newtons when the stone is. The similar model question, students, here when the 2 kg stone, when you are going to be moving in a vertical circle, so here it's given as, this is the 2 kg stone you are going to be rotating, and here a string length is given as here 1 meter, it's nothing but radius you can take when it's moving in a vertical circle, and speed is given, tension at the bottom. So here first you have to calculate mg value, mg which will be equal to, here mass is given as 2 into 10 you can take, this is a 20 newtons, and here the centripetal force value mv square by r you can take. Mass here will be getting as 2 into, with the constant speed is given as 4 meter per second. 4 4 is 16 by radius you can take as, it's a 1 meter you can take, which is nothing but 32 newtons. So tension at the bottom in the sense, here you can take as mv square by r plus, here you can take as mg you can take. So mv square by r value will be getting as 32 plus mg will be getting as 20, which is nothing but will be getting as 52 newtons. Tension at the highest point in the sense, here at the top of the circle is nothing but mv square by r minus mg. This explanation I have given students already. So here you can get as 32 minus 20, which will be equal to 12 newtons you are getting. So here tension in the string is at 52 newtons in the sense, that doesn't mean here. So where the position of the stone in the sense, here at the bottom of the circle you will be getting. So this will be the correct answer. Now let us take the next question. A weightless thread is given, can support the tension up to 10 newtons. A stone of mass is given as 0.5 kg is tied to it, and it's going to be revolving in a circular path of radius is 2 meter in a vertical plane. So then the maximum angular velocity of the stone they are asking. So it's going to be withstand here up to 30 newtons is given, students, and here it's going to be revolving in a circle. It's a vertical circle, it's given. Maximum angular velocity they're asking. So it's a weightless thread is given, and here it's going to be supporting some weight, and here it's given as 30 newtons is given. Right here its radius is given as 2 meters is given, and it's moving in a vertical plane. The maximum angular velocity they're asking. So here maximum angular velocity, in the sense tension you will be getting at the lowest point will be maximum. In terms of angular velocity, T equal to generally mv square by centripetal force, the formula will be getting as mv square by r. It's nothing but in terms of angular velocity you can write it as mr omega square. Now you can take here, this is mr omega square, and this is the maximum value you can take. At the lowest point here you will be getting as mv square by r plus mg will be getting. So already tensional force is given as here 30 Newton is given. So here you just simplify this one. Mass you have to take common and you just bring this side. T maximum by mass, which will be equal to here r omega square maximum will be left over, plus here you can get it as g. And here T maximum is given as here supported tension up to 30 newtons, and here its mass is given as 0.5 kg, which will be equal to radius is given as 2 meters. We need to calculate the maximum angular velocity plus g value you can take as 10 you can take. So 0.5 you can take as 1 by 2, 2 it will come to the numerator, 2 into 30 will be 60. So 60, this minus plus 10 you have to bring this side. So minus 10, here 2 into omega maximum square you will be getting. It's 50, which will be equal to 2 into, here you can get it as omega maximum whole square, 25 times you will be getting. And here omega maximum whole square, which will be equal to 25 will be getting. Then omega value will be getting as, it's a 5 radian per second will be getting. This is the angular velocity, radian per second. Let us take the next question. The next question says here, a weightless thread can bear the tension up to 3.7 kg weight. A stone of mass is given as 500 gram is tied to it, and it's going to be revolving in a circular path of radius is 4 meters in a vertical plane. Then the maximum angular velocity of the stone they are asking. So here maximum tension right can be bearing, in the sense T maximum value it's given as 3.7 kilogram weight it's given, students. So 1 kilogram weight equals will be getting as 10 newtons will be getting, so that the T maximum value will be getting as 37 Newton will be getting. So it's going to be getting the maximum tensional forces at the lowest point will be getting. Then tension at the lowest point you can take, here it's nothing but mr omega square, plus here will be getting as mg will be getting. Then here they are asking then the maximum angular velocity. So here this is, here will be getting as 37, and the mass when you are taking, then the maximum angular velocity, mass is given as 500 grams is given. It's nothing but 0.5 kg you can take. Mass you have to take common and you just bring it left side. So 37 by mass will be 500 grams. I am writing as 0.5 kg, which is nothing but omega square maximum. This is the maximum value you can take, maximum into r value. Radius is given as 4 meters, plus g value you can take as 10 you can take. 37 by 0.5, 1 by 2 you can take, 2 7s are 14 and 2 3s are 6, plus 74 will be getting, and this 10 you have to bring this side, which is nothing but, so omega maximum whole square into 4 will be getting. 74 minus 10 will be 64 will be getting, and omega maximum square into 4 you can take 4 16 times. Then omega square maximum will be getting as 16, so omega value will be getting as 4 radian per second will be getting. It's a 4 radian per second is the correct answer. Let us see the next question, students. A hollow sphere has a radius is given as 6.4 meter. So here it's given as a hollow sphere, it's given like this. It's a hollow sphere it's given, and here a minimum velocity required by the motor cyclist at the bottom to complete the circle will be. So here a person, he is on the bike, he is going to be completing the vertical circle in the circular motion is going to be doing. If you want to complete the total complete circle with what is the minimum velocity is required at the bottom. So this is a hollow sphere, just imagine. So to complete the circular motion here, so what is the minimum velocity is required in the sense here at the bottom. So here V minimum here in vertical circular motion will be getting as root over 5 GR will be getting. It's 5 into G value you can take as like 9.8 like that, you just take into radius is given as 6.4 it's given. So just simplify this one, students. Here V minimum value will be getting as nearly, it's a 17.7 meter per second LV. This is the correct answer. Let us take the next question. A particle is tied to 20 centimeter long string. It performs the circular motion in a vertical plane. What is an angular velocity of the string when the tension in the string at the top will be 0? So here what is an angular velocity they are asking. Here at the topmost point tension is 0 in the sense. So a particle is tied here at the topmost point you are taking, and this is a particle you can take here. This is a particle you can take at the topmost point. Tension will be 0, it's given. T, it will be acting like this. Mg also here it's going to be acting downwards. So here you can get it as tension at the topmost point, it is 0. That means here this is generally will be getting as P plus mg, which is going to be providing the centripetal force, mv square by r will be getting. Then T equals to, at the topmost point the formula will be getting as mv square by r minus mg will be getting. And here tension force is 0 in the sense here will be getting as mv square by r, which will be equal to minus mg. So mv square by r, which will be equal to, will be getting as mg. Here mm gets cancelled, so here we will be getting as v equal to, will be getting as root over gr you are getting. So when you are taking here angular velocity, they are asking v equal to r omega you can take, which will be equal to root gr. With this omega, when you are talking this is omega, the formula will be getting as root over g by r will be getting. This is the formula angular velocity. So g value 9.8, radius is given as 20 centimeter, so you can take as 0.2 meter. So 98 by 2, remove this decimal here, it's a 49 will be getting, that is nothing but 7 radian per second will be getting. 7 radian per second is the correct answer. Let us take the next question. A ball is moving to and fro about the lowest point A of a smooth hemispherical ball. So here a ball is given, and here it's going to be moving in a to and fro manner about the lowest point. In a smooth hemispherical ball is given, right? So if it is able to rise up to a height of 20 centimeter on either side of the A, its speed at the A they are asking. It's a hemispherical ball is given, students. Here the point here at the lowest point is given as A is given, and now here about this point, now the ball is going to be moving in a to and fro manner, it's given. Here it's going to be moving in a to and fro manner. So here it's able to rise to a vertical height. Its a vertical height is given as 20 centimeters, students. Here on the either side of the A, its speed at the A must be there asking. Speed doesn't mean here at the lowest point it will be having kinetic energy, and here at the highest point here it will be 20 centimeters height it is acquiring. In the sense here you can take as it acquires the potential energy. So here by energy conservation you are talking, law of conservation of energy. By energy conservation you can take. So here this loss in kinetic energy while it's moving up, loss in kinetic energy can be stored as gain in potential energy you can get. So loss in kinetic energy, that doesn't mean half mv square, which will be equal to gain in potential energy is mgh you can take. So mm gets cancelled. Here you will be getting as v square, which will be equal to root 2gh, and v equals to, you can get it as square root of 2gh will be taken. So here they are asking here, if it is able to rise up to 20 centimeter on either side, its speed at the point A they are asking. So here at the point A, here which you can take as 2 into g value, you can take as 10, you can take, it's going to be rising to the 20 centimeter height. So directly you can take 0.2 meter, you can take 0.2 into 10 will be 2, will be getting 2 2s are 4, square root of 4 in the sense at the point A you will be having the 2 meter per second will be getting. It's a 2 meter per second is the correct answer. Let us see the next question. A stone of mass is given as m. It is tied to a string and its move in a vertical circle of radius r is given, making n revolutions per minute. So here frequency is given, students. Here f equal to n revolutions per minute it's given. It is 60 seconds. The total tension in the string when the stone is at the lowest point they are asking. So here a stone mass is given and here it's tied to a string and it's moving in a vertical circle. It's a vertical circle, it's going to be moving. Now here let us talk about here. Its radius is given as r, it's given, and here it's making n revolutions per second in minute it's given. Total tension at the lowest point. So tension at the lowest point here you can get as, that is m omega square r plus here you can get it as mg you can take. So here when you are simplifying this one here okay, mg you can take, m you just take common here, g plus here you can take as omega square r you can take. So omega is nothing but here again you can talk about omega equals to 2 pi f. The formula will be omega equals to 2 pi f you can take. It's you can take as 2 pi f whole square means you can write it as 4 pi square f square into you can take as r you can take. Right here the frequency value here you have to substitute, students. Here f square it's given, so here you can calculate this value. Tension at the lowest point m into g plus here 4 into pi square into f square, in the sense here we got it as, this is n square by here 60 that will be getting as 3600 will be getting into f square into r you can take. So here 900 times it is going, so that the tension at the lowest point will be getting as tension at the lowest point m into g plus here it is pi square n square r by here will be getting as 900 will be getting. So this is the correct answer. Let us see the next question. As per the given figure, to complete the circular loop, what should be the radius if the initial height is given as 5 meters? So here it's going to be moving down, students. Here to complete its circle, here it requires a minimum velocity. That minimum velocity, you know the formula, root 5 gr. Right, to complete the circular path, minimum velocity at the lowest point will be getting as root over 5 gr you can take. It's nothing but here conservation of energy principle according to law of conservation of energy. Here it has been converted into like kinetic energy, it has been converted into potential energy, or it's sorry here potential energy, now it has been converted into the kinetic energy. So here you can take as mgh you can take, which is nothing but here you can get it as loss in potential energy, which will be equivalent to you can take as gain in kinetic energy you can take in this case. That is nothing but half mv square will be getting mgh. To complete its circle, here velocity at the bottommost point you require as 5 gr, root 5 gr. When you are doing square root, here will be getting as 5 gr you can take. So here mm gets cancelled and here on gg gets cancelled. Here h value will be getting as, this is 5 by 2 into r will be getting. So here they are asking here radius they are asking, then r equals to here you can take as 2 by 5 into h you can take. 2 into initial height is given as 5 by 5 you can get. 5 gets cancelled. So here when it is completing the circle, that radius value it will be giving as 2 meters. So 2 meter is the correct answer. Let us see the next question. The next question says a body crosses the topmost point of a vertical circle with a critical speed. Its centripetal acceleration when the sting is at the horizontal, they are asking. When the sting is at the horizontal position, in the sense, students, here you can take. This is a sting, suppose here it's going to be moving. So this is the initial position of the string you can take, students. Here a body crosses the topmost point with a vertical circle with the critical speed. Its centripetal acceleration when the string is horizontal. Now here this is the position of the string you can take when it's horizontal. So here at the bottommost point here we will be getting as v equal to, will be getting as the minimum velocity to complete its circular path will be root 5 gr, and at the topmost point we will be getting as critical velocity will be getting as root gr, students. So here if you want to calculate the velocity at any point in the sense, here you can take the basic formula you will be getting as gr into, here you can take as 3 plus 2 cos theta under root. So when the string is making here horizontal in the sense, theta value will be getting as 90 degrees will be getting. You just put the value here. V equal to, here will be getting as gr into 3 plus 2 into cos 90 will be getting with the horizontal. It will become 0. So here the velocity will be getting as root 3 gr will be getting. So velocity at the horizontal will be getting as root 3 gr. So at this point here the centripetal acceleration they are asking. So at this point here centripetal acceleration it's going to be acting towards its center. So AC equal to, here will be getting as v square by centripetal acceleration. V value you are getting as 3gr by r will be getting, rr gets cancelled. So centripetal acceleration value will be getting as root 3g will be getting. Let us take the next question. A simple pendulum oscillates in a vertical plane when it passes through the mean position. The tension in the string is given as 3 times the weight of the pendulum of the block. What is the maximum displacement of the pendulum of the string with respect to the vertical they are asking? What is the maximum displacement? So here it's given as one simple pendulum is going to be oscillating, students. Here this is a simple pendulum you can take. It's going to be oscillating. When it passes through the mean position, the tension here it's given. It's a mean position you can take. So here tension at the mean position is given as 3 times of its weight of the pendulum bob. So what is the maximum displacement of the pendulum of the string with respect to the vertical? So let us take, this is the maximum displacement of the simple pendulum, which is making an angle theta with the vertical you can take. Right? Now here tension at the mean position or tension at the lowest point in the string will be getting as, so here you can take as mg plus, here you can take as mv square by r you can take. This is the tension at the lowest point. So here tension at the lowest point is given as 3 times of the weight of the body, 3 into mg you can take. So mg plus, here you can take as mv square by r will be getting. That means here mv square by r here will be getting as, this is 2 mg will be getting, you just bring this side. That means here mm gets cancelled, here v equals to, here will be getting as square root of 2gr will be getting. So at this point here the velocity will be getting along this direction. Here velocity here at any point with certain angle in the sense, here again you have to apply the conservation of energy principle, students. And here this velocity at a particular displacement, this velocity at a particular displacement will be getting as 2gr into, here will be getting as 1 minus cos theta. So this is a formula, velocity for a particular displacement, students. And here which will be equivalent to root 2gr you can take, and you just cancel the square root on both sides, and here you can take as 2gr gets cancelled. Here it's a 1 minus cos theta which will be equivalent to 1 will be getting, and this side here will be getting as cos theta equal to, here will be getting as 0 will be getting. That means here theta value will be getting as 90 degrees will be getting. So here maximum displacement will be getting as 90 degrees will be getting. So here the string will be at this position. This is a 90 degrees. Let us take the next question, students. Here they are given as a full bucket of water is revolved in a vertical circle of the radius 2 meter. What should be the maximum time period of the revolution so that the water does not fall in the bucket? So here this model we have seen, student, already here. Let's say here it's given as bucket without falling. Here you are going to be moving the bucket. Here inside, here water will be present, and here you can take omega. Here the formula will be getting as V equal to, here minimum velocity at the topmost point, critical velocity is required as root gr. So V equal to r omega you are taking, which is nothing but g into r you can take. Then omega equals, here will be getting as g by r will be getting. So here they are asking what should be the time period they are asking. Omega equals, you can take as 2 pi by t, which will be equal to root over g by r you can take. With this time period which will be equal to 2 pi into, will be getting as root over r by g. T equals to 2 pi into root over r by g will be getting. Radius is given as 2 meter. So 2 pi into, here you can take as 2 by g value you can take as 10 you can take, students. Here root 10 in this sense nearly will be getting as 3.14. So here 2 pi by pi into root 2 you can take. This pi gets cancelled. So here time value will be getting as 2 into root 2 seconds we are getting. So 2 into root 2 seconds in the sense nearly will be getting as 3 seconds will be getting, which will be equivalent to 3 seconds. 3 seconds is the correct answer. The maximum speed and the maximum and minimum tension in the string, it's a whirling in a circle of radius is given as 2.5 meter with a constant velocity, so and the ratio is given as 5:3. Then its velocity they are asking, students. Now here tension you will be getting as maximum and minimum tension. Maximum tension you will be getting at the lowest point. The formula will be getting as mv square by r plus mg will be getting, and minimum tension will be getting at the highest point. It's a constant velocity, means uniform circular motion they are asking. Here mv square by r minus mg you can take. Now the ratios they are asking, but initially here maximum and minimum tensions ratios is given. Then the velocity they are asking, or the velocity of the body or velocity of the particle they are asking. So here you can take T maxima by T minima you can take, students, which is nothing but here you can take as mv square by r plus mg by, here you can take as mv square by r minus mg you can take. So here this value is given as tensions ratio is given as 5/3 it's given, which will be equal to m you have to eliminate by taking common on both numerator and denominator. So when you are taking LCM, v square plus rg by r will be getting by v square minus rg will be getting. R and r you have to remove in both numerator and denominator. So when you are simplifying this one here, this is v square plus rg by, here will be getting as v square minus rg you are getting. You just cross multiply this one, students. 5v square minus 5rg, which will be equal to 3v square plus 3 into rg will be getting. So 5v square minus 3v square will be getting as 2v square, which will be equal to 5 plus 3 will be getting as 8rg will be getting. So 4 times it is going here, v square which will be equal to will be getting as 4gr will be getting. Then v equal to, here you can take as root 4gr you can take. So g value here v equal to 4 into g value you can take as 9.8 you can take, and here its radius value is given as 2.5. It's an under root will be getting. So when you are simplifying this one, here you will be getting as root over 98, you will be getting this in meter per second.